Last on our docket here for the identities are the half-angle identities. We don't do a lot of work with half-angle identities, I'm going to be honest, but there is a need for me to show you mostly how to use the half-angle identities. Okay, so here's your three identities for the half angles, sine, cosine, tan. I want you to notice in particular the plus and minus here, plus and minus, plus or minus, plus or minus. That's the unique piece to this identity. All of the other identities, the sign for the ratio is built into the formula because it is based on the unit circle and reference angles, blah, blah, blah. With the half angles identities, that is not true. And so the hardest piece for people to remember, because the identity itself is very easy to use, a couple things I want to point out. Notice they all use the cosine ratio. Okay, tangent, because tangent is sine divided by cosine, if you take this radical and divide it by this radical, you will end up simplifying that complex fraction into just 1 minus cos x over 1 plus cos x, all into the radical. So, and again, don't need to memorize. These are given on the reference sheet. So all of the things that we've done in this identity unit are actually part of the reference sheet. What's not part of the reference sheet is knowing how to handle this plus and minus for each of these. So that's what I need to show you on the next slide. Okay, so here we have an example. I'm giving you a cosine ratio of 4/5. I'm telling you it's in quadrant 4. Hello. Okay, I'm back. So what I want to do is grab my identity for the cosine of the half angle. Cosine of the half angle is the square root, or it's plus or minus, the square root of 1 plus the cosine of A divided by 2. The beauty here is I know the cosine of A. It's given. So all I got to do is plug in. So I'm going to take plus or minus. It's going to be 1 plus the cosine of A is 4/5, all divided by 2. I need to clean up what's under that radical. So I'm going to get as a fraction 9/10. Now you can use your calculator. 1 plus 4/5 turns out to be 1.8 on your calculator divided by 2. You get 0.9, which is your 9/10. Make sure that you are not working in decimals, that you're working in fractions. Now, many times these are multiple choice questions, and sometimes your answer will be like this with the fraction under the radical, but most of the time we know that we're not allowed to leave our answer with an irrational denominator, because this is really square root of 9 over the square root of 10. Now the square root of 9 is nice, that's 3, but the square root of 10 is irrational. So what I'm going to do is I'm going to multiply this by radical 10 over radical 10 to rationalize it. At the same time, I'm going to simplify that to my 3. So what I'm going to end up with here is 3 radical 10 over 10. Now what I have to deal with is this plus and minus and where that comes in. So here's the thing you need to realize. The original angle was in quadrant 4. So I need to figure out where its half angle will fall. Okay? And it just so happens that when you take an angle in quadrant 4 that is somewhere between 270 and 360 and cut it in half, the half angles will fall between 135 and 180. And so 135 and 180 sit here in quadrant 2. So what I can tell you is that the half angle will be in quadrant 2, because the original was in 4, the half angle will be in 2, and in quadrant 2, cosine of A is negative. So I'm going to pick the negative piece. Okay? And so my answer will be negative 3 radical 10 over 10. You have to choose one of those. with that in mind, let's look at all the quadrants. Quadrant 1 is from 0 to 90, between, not including, which means the half angles for any quadrant 1 angle. So if angle A is in quadrant 1, then its half angle will also be in quadrant 1. Because remember, the interval for quadrant 1 is from 0 to 90, which means the half angle will be half of 0, 0, half of 90 is 45. Okay? In quadrant 2, if angle A is in quadrant 2, that means that the interval in which it falls is between 90 and 180. Right? Its half angle then will be in quadrant 1 because half of 90 is 45, half of 180 is 90. So the half angle for quadrant 2 is 1. In quadrant 3, if angle A falls in quadrant 3, that means that it's falling between 180 and 270. And so its half angle then will go from 90 to 135, which is quadrant 2. And in quadrant 4, if the angle A is in quadrant 4, that means that it is somewhere between 270 and 360, which means half of A is going to be between 135 and 180, which happens to be in quadrant 2. So what I can tell you is that this is where the half angles for quadrant 1 fall. This is where the half angles for quadrant 2 fall. This is where the half angles for quadrant 3 fall. And this is where the half angles for quadrant 4 fall. So sine is going to always be positive because sine is positive in 1 and 2. Cosine is positive in 1 and negative in 2. So if your original angle is in 1 or 2, the half angle will fall in 1 where it's positive. If the original angle is in 3 and 4, then the half angle will fall in quadrant 2 where it is negative. And same with tangent. Now why do we have the plus and minus for sine? Because there's no guarantee that your angle has to be between 0 and 360. If I said to you, I have an angle of 500, the half angle would be 250. And so even though 500 falls in quadrant 2, where sine is positive, 250, its half angle, falls in quadrant 3, where sine is negative. So you do need to figure that out. Let me show you one more example of this, a little bit more involved. This time I'm giving you a sine ratio of negative 12/13, and I'm telling you that angle A is in quadrant 3. So if angle A is in quadrant 3, I'm going to figure out where's my half angle going to be. Now keep in mind, you don't have to memorize that little chart thing or anything. Just pick any angle in quadrant 3 and cut it in half. And where that ends up is where all of your angle or quadrant 3 half angles will end up. So picking a nice easy angle in quadrant 3, I'll pick, I don't know, 200. Nice, clean, easy angle. Half of 200 is 100. 100 sits in quadrant 2. So the half angle is going to be in 2. What I want you to do here is find for me, I'm going to do a tougher one, the tangent of the half angle. Okay? So because I'm in quadrant 2, I know it's going to be negative. Tangent is negative in quadrant 2. Okay. So my formula off the reference sheet, plus or minus, and then it's going to be 1 minus the cos of A over 1 plus the cos of A. So I already know it's going to be negative, so I'm going to get rid of the positive. I'm going to go with the negative. Now, the problem is, I know the sine ratio, I need the cosine ratio. So I'm going to need to go over and build a triangle in quadrant 3. if this is A, sine is opposite over hypotenuse, which leaves the missing piece of 5. So the cosine of A is going to be negative because I'm in quadrant 3. Cosine is adjacent over hypotenuse. So the cosine ratio I'm going to use here for cosine of A is negative 5/13. And I'm going to use that twice, here and here. So I'm going to place it in 1 minus negative 5/13 over 1 plus negative 5/13. Just be careful here with your signs. I'm going to let my calculator do a little talking. If I do my numerator, 1 minus negative 5/13, I'm going to end up with 18/13. Now I'm doing this in my head, so that's why I'm using fractions, not decimals. If I do 1 plus negative 5/13, I'm going to end up with 8/13. And then when I divide that, it's the same as multiplying. So again, because I'm doing this by hand, I'm showing you every step. That would be the same as 8/13 times, or 18/13 times the reciprocal of the denominator, which is 13/8. Boom, boom. This is going to simplify to negative under the radical. 18 over 8 will reduce to 9/4. Oh, that's unusual. That's a perfect square. You normally get perfect squares. Typically, there's going to be a radical in your answer, but in this particular case, this was kind of nice. So I'm going to end up with negative 3/2 as my final answer for the tangent of the half angle. So just to show you a different, one of the formulas and how to work it through. But again, your calculator can do a lot of this for you. Just keep in mind that you don't want decimals under the radical. You want it to be fractions. And if the denominator doesn't disappear, you want to be able to rationalize that. Okay, so we're going to do a little bit of work with those also. And this is kind of wrapping up our identity piece, or at least part of it. So we will see you in class tomorrow.